Good morning, my student. So, as per your request, I am starting a new series on nuclear physics. So, we will learn slowly in details of nuclear reactors, how it works, the basic dynamics behind it, and all. Okay. So today in the first lecture we are going to learn the basics of fission. We know already, so let us start. So nuclear fission. What is nuclear fission? So nuclear fission is a subdivision of a heavy atomic nucleus such as that of uranium-235 or plutonium into two fragments of roughly equal masses. Approximately, there is some change of masses, means the sum of the mass of the parent particle and the daughter particle, there will be some difference which is called mass defect. Okay, so this process is accompanied by the release of a large amount of energy following the relation of that theory of relativity, E is equal to mc square. Okay, so when the nucleus of uranium-235 is bombarded with a thermal neutron of high kinetic energy, then this neutron is absorbed by 235 and another unstable nucleus of 236 is formed and immediately is scattered into barium and krypton, which also release 3 neutrons. So this is this already we know. Basically, this is the basics of fission. Okay, we should know why we are learning it. Its importance. Because this will release huge energy. So that exercise we will do simply today. In the first lecture, then we will understand the power, the power which is power and energy which is produced by fission is enormous and that can be utilized. Okay, even though today we are talking about so many advanced things, okay, like our computer is in our hand, everything is a matter of a click, but still today millions of people are not connected with grids. Okay, so to produce the quality life, power is must. So we can utilize this nuclear fission to enlighten the life of the people who are still not connected with grid. So here, this is the simple equation. This is the uranium-235. When it is bombarded with a thermal neutron, it's scattered into these things. Okay, it is chemically balanced. Now if I am neglecting the mass of the electron because it is negligible, so the mass defect is the total mass of this minus the total mass of this. So this I am taking unit is atomic mass unit. So this is the AMU of uranium-235. This is neutron, this is barium, this is krypton, and this is 3 neutron. So the mass defect is, the difference of mass is 0.21537. Now if you convert that AMU to gram, so you have to multiply it with this factor. And if we convert the gram to kg, then you have to divide it by 1000. So this much kg. So now the energy, as per the theory of relativity, mcs square. So the velocity of light is 3 into 10 to the power 8 meter per second. So that means 9 into 10 to the power 16. So the energy produced from a fission nucleus of uranium-235 is 3.218 into 10 to the power minus 11 joule. So let us calculate how much energy we can get from 1 gram of uranium-235. So number of nucleus present in 1 gram of uranium-235 is, means we know the 1 mole of atom contains 6.023 into 10 to the power 23 number of nucleus or atom, which is Avogadro number. So 1 gram, so mass number of this uranium is 235. So 235 gram of uranium contains this much of fissile nucleus. So 1 gram of uranium-235 contain this much nucleus. So each nucleus, already we calculated, each nucleus produced this much joule of energy. So this many nucleus will produce 8.247 into 10 to the power 10 joule of energy. So it's a huge energy. Now joule to kilowatt hour, if you convert, you have to multiply with this factor. So it is 2.29 into 10 to the power 4 unit, board of trade unit or kilowatt hour or unit. This much of energy can be produced from 1 gram of uranium or the fissile atom. It's a huge energy. Let us do the further comparison. So when we are burning carbon, coal, it will produce carbon dioxide and this much joule of energy, 6.4087 into 10 to the power minus 19 joule. Similarly, 1 gram of carbon contain Avogadro number divided by its mass number. This many atoms of carbon can produce this much joule. Okay. Now if you convert into kilowatt hour, so this is this much. Okay. You see, this is very less, this much unit only. That there the factor was 10 to the power 4, 2.29 something into 10 to the power 4, and here it is 10 to the power only minus 3. So how negligible it is. Now if we do a comparison, so 1 gram of fissile nucleus of uranium-235 can produce 2.29 into 10 to the power 4 unit of energy, and 1 gram of coal, it can only produce 8.93 into 10 to the power minus 3 unit. So to get the energy equivalent to 1 gram of uranium-235, how much coal is to be burnt? So that is this divided by this. It is 10 to the power 4 by 10 to the power minus 3, which is 10 to the power 7. If you do that, it is coming 2600 kg. Now you can understand, to get the energy which is produced by a simple fission of uranium-235, we need to burn approximately 3 tons of coal, and it will produce that many tons of carbon dioxide. Means we can calculate how much from the equation. Okay, from this equation you can calculate. So this is 12 and this is 12 plus 32, it is 44. So 12 gram of carbon produce 44 gram of carbon dioxide. So this will produce this much kg of carbon dioxide. Okay, so it is approximately, you can tell, this is 3, it is 11, so 9, so 99, so 9900 kg of carbon dioxide it will release to the environment. Now you can compare in terms of pollution. Okay, so the nuclear energy is must for the country because it's a green energy, and to burn this many tons of coal, you need a very big furnace or something, that arrangement. The area will be huge. So for a thermal plant it needs more area, and foremostly you see the figure of the pollution. So you can conclude that nuclear energy or the nuclear reactor is a concentrated power source compared to, you can tell, this is a distributed source. You can take any other renewable source also, that solar and wind, which need very huge area. This is also one factor. So the country like India, it needs the nuclear power to enlighten the life of the people who are in dark. Nuclear power is must. So with that I am concluding the first lecture, and slowly we will learn so many things. How the nuclear reactor can be controlled, this reaction can be controlled, otherwise it will become bomb. How nuclear weapons can be designed it. We will give a very basic, I will give a very basic idea, and the reactors, type of nuclear reactors, etc. So hope you can understand the very basics of nuclear reaction, nuclear fission. and how it is useful, how it is efficient to produce power. Thank you, students. Thanks for your patience. Bye.